Multiplicative comparison. On the pre-assessment, you had a problem that asked you to write an equation and solve a multiplicative comparison problem. Now, most people were able to find the answer to the problem, but actually writing an equation was a little trickier. So we're going to go through in this video how to write an equation and then solve that equation of a multiplicative comparison problem. So a multiplicative comparison problem, they compare the characteristics of two objects using multiplication. Sometimes we know the value of the object that is bigger or older or faster. Sometimes we know the value of the object that is smaller or younger or slower. And sometimes we know how many times bigger, older, faster one object is over the other. Keep in mind that all multiplicative comparison problems follow the same structure. Something times something gives you something else. We use a variable for the value we don't know, and then we fill in the rest of the equation. It's important to understand that often we use division to solve the equations, but we actually have to write the equation using multiplication because that's true to the language of the problem. So let's take a look at that problem with Mrs. K. Mrs. K is 5 times as old as her son. If she is 35, how old is her son? So we know that she is 5 times as old as her son. So I'm going to go ahead and underline that I know that she's 5 times as old as her son. I know that she is 35, and I know that I'm trying to find out how old her son is. That's our variable. That's what we're trying to figure out. So because it's a multiplicative comparison, I'm not going to put how old is her son on this side of the equal sign. I'm going to actually put her age over here. She's 35. Because if we take her son's age, and we'll give her son S, times 5, because she's 5 times older than her son, we're going to get her age, which is 35. Sometimes you might see this written as 5s equals 35, because when we're doing multiplication and equations, we always put the number that we're multiplying, like 5, to the left of the letter. So this would be 5s. 5 of her son's age equals 35. So if I wanted to solve this using a visual model, I'm going to set up my number line, and I'm going to put 35 as the target number over here, and I'm going to show that you have to take her son's age 5 times to get to 35. And so if we know that takes 5 bumps, we know that each one of those would be worth 7. If I wanted to solve it using the canceling method, I'm going to say 5s equals 35, and I'm going to divide each side divided by 5, because I know there are 5 of some number in here. So if I divide that by 5, I will get whatever that some number is, and it's 7. So her son's 7 years old, and I can substitute that in, and that makes sense in my original problem, and they are equal, so I know it to be true. Now, we're going to do another problem, and you're going to see how this one's just a little different. I'm still going to set it up in my regular structure with the multiplication, but it's going to look a little different. Mr. L has 2 dogs. Scruffy is 12 inches high at the shoulders, and Tuffy is 24 inches high at the shoulders. How much bigger than Scruffy is Tuffy? Here, let me fix my error there. Is Tuffy. So in this case, I know that Scruffy is 12 inches, and I know that Tuffy is 24 inches. And we're trying to figure out how much bigger. So in this case, what we're trying to figure out is the number we're multiplying by. We're trying to figure out how many times bigger is Tuffy than Scruffy. So I'm going to put 24 over here because this is Tuffy's height. And I'm going to put 12 over here because that's Scruffy's height. And we're trying to figure out how many times bigger? So I'm going to use T. That's my variable. Scruffy's height times some number gives us Tuffy's height. So I would write this as 12T equals 24. You can write it as 12 times T. That's definitely representing the problem. Often we'll drop that multiplication symbol in there as we continue to develop our equation solving skills. So we know that I could set up with a visual model. I'm getting to 24, and if I have 12 jumps to make, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're trying to figure out how big each one of those jumps are, and we know them to be 2. And if I want to use a canceling method, I'm going to divide each side by 12, because there are 12 of some number in 24, and I end up with 2. So we now know that Tuffy is twice as big as Scruffy, but we have to make sure we set up that number sentence up here with the variable in this space, because we are talking about multiplying that one dog's height times 2.